All right, we're going to take a look at lesson 4.6. This video is going to help you understand how to solve rational equations. Again, solving an equation, remember, is just finding the value for the variables that would make the equation true. Okay, I know you're probably watching this on your iPad or phone in the classroom, so please make sure you are listening, okay? Keep your volume turned up so you can hear the things that I'm saying. It's going to be very helpful for you to hear my explanation to go along with this. Do not just pause the video and copy things down. This is not going to make a lot of sense that way. Make sure you're following along the best you can by listening and copying down at the same time. If you need to pause the video at any moment, go ahead and do that to copy things down, but I do want to make sure you are understanding some of the basics here. And so I'm going to give you the steps for solving rational equations, and we're going to write these down. I'm actually going to write them down and then show them all at once. So you can pause that video at that time to copy that down, and then I'll read through them. All right, these are what you're going to have copied down. If you need to pause the video here to copy this down, make sure you have it paused so you can get all those written down. But I'm going to walk you through these. The first thing you always want to do is to factor first. If you can, factor the denominators especially. That's going to really help you out as you walk through this. Really, it's the denominators that you would need to factor first, okay? And I'll explain that as we go. But then once you've done that, we're going to follow these 4 steps. We want to identify the LCD. LCD is least common denominator. In fact, if you want to write that down, that'd be a good idea. Least common denominator. All right, we've been doing that with some of the other simplification lessons we've talked about so far. Then we want to, once we identify the least common denominator and we've written down our excluded values, we want to take that least common denominator and actually multiply both sides of the equation by that LCD to distribute through on one side of it usually, but that will clear the problem of all of our fractions. Okay, we will no longer have rational expressions when we do that. And that's why it's important to also identify the excluded values, because by clearing that out, it actually might give us answers that aren't really answers in the long run. And so we'll look at that in our last step when we check our solution. But first, once you get rid of the fractional parts, you can solve the equation. Now, if it ends up being just a straight linear equation, there's no x squared or third power or anything higher than that, then you can just solve it. But if it is a quadratic, if we have an x squared, we would need to set that equal to 0 to solve that. And I'll show you an example or two like that. And then, like I said, you want to check your solution to make sure that it's not one of your excluded values, and also check to make sure that it makes both sides true. Make sure it's not an extraneous solution. So let's take a look at our first example. Okay, and our first example here, all right, we want to state the excluded values first. Before I give you any other instruction, we can look at the denominators and realize in every one of these fractions, the only thing that would make the denominator 0 is if a was 0. So that's my excluded value. A cannot equal 0. Okay, and then I want to identify the least common denominator. Well, the denominators are a, and 3a. So the least common denominator is 3a. So I'm going to multiply both sides of my equation by 3a. But when I multiply this side by 3a, I'm going to distribute 3a to both of these fractions. So when I do that, in this first fraction, the a's cancel, and I'm just left with 3 times 2a minus 4. Okay, because those a's canceled. And on this one, the a's cancel again, but 3 times 1 is just 3, so I write plus 3. Bring down my equal sign. On this side, 3a cancels completely with 3a, so the only thing left is a minus 6. I no longer have a rational equation. I just have a straight linear equation. The highest power is just a to the first. So I can distribute here. 3 times negative 4 is negative 12. Combine your like terms. Negative 12 plus 3 is negative 9. And we can solve this. All right. Now to remember to solve, we want a by itself. So I'm going to subtract a from both sides. 6a minus a is 5a. And then I'm going to add 9 to both sides. When I add 9 to both sides, we get 3. And then to finish solving, we divide by that 5. And so a ends up being 3/5. Now, this is not my excluded value. And if I plug in here, it's going to give me some kind of weird answers here, but it would work, okay? And this answer does work, all right? It's going to make everything simplify exactly like it needs to. All right, so let's try this next one. Number 2. When I'm looking at number 2 here, I again want to identify excluded values. Well, the x is on bottom here. The only thing that would make any denominator 0 is if x equals 0. So that is my excluded value. I can't have x equals 0 as an answer. And now I want to go through and find the least common denominator. Well, the least common denominator here, it can't just be x, because this has x times x. And it can't just be x squared, because this also has a 4 times x squared. So this 4x squared is actually your least common denominator. So I'm going to multiply both sides by 4x squared. On this side, that cancels completely. This left side of my equation is now just 1. On this side, 4x squared over x squared, because 4x squared times 1 is 4x squared. The x squareds cancel, so that's just a 4. Bring your minus sign down. And then 4x squared times 1 over x, I'm going to cancel one of these x's. So this is just minus a 4x. Well, that's a pretty simple equation to solve. First thing I do is subtract 4 from both sides. That's negative 3. Okay? And then that leaves negative 4x here, so I would divide by negative 4. The negatives cancel, so x is 3/4, which is not my excluded value, so that is my answer. That is my solution. Okay? So as we continue on, the problems get a little more complex looking, but again, this is why I said it was so important to factor first. So this denominator is p plus 2, so is this one. This will probably factor into p plus 2 and something else, and if we look at it, the numbers that would multiply to equal 12 but add up to 8 are 6 and 2. So this denominator is actually p plus 6 and p plus 2. So that actually is the least common denominator. It also helps me see what my excluded values are. P cannot equal negative 2 or negative 6. Those are the only excluded values I have. So now I can take that as my least common denominator and multiply both sides by that. P plus 6, p plus 2. And I want to leave it in factored form. P plus 6, p plus 2. Okay, when I multiply all of that times this first fraction, or this first rational expression, the p plus 2's cancel. So I have a 4 times p plus 6 minus, when I multiply all of this times this rational expression, remember this is the factored form of that denominator, so it completely cancels, leaving just 3. That equals, on this side, when I multiply this by this rational expression, the p plus 2's cancel, so I'm left with just a p plus 6. And now I can start to simplify and solve. I distribute, giving me 4p plus 24 minus 3 equals p plus 6. Combine your like terms here. 4p plus 21 equals p plus 6. Subtract p from both sides. I'll move over here. Gives you 3p. Subtract 21 from both sides. We get negative 18. I'm sorry, negative 15. I'm glad I have erasable pen. Negative 15. And divide by 3. We get p equals negative 5. Now, make sure it's not one of your excluded values, and it's not. All right, I want to keep on moving. We're actually going to skip number 4. Okay, I'm sorry, we're not going to skip number 4. That was one of the ones I wanted you to do. So take that back. Let's go ahead and take a look. We want to look at the factored forms of these. Okay, now these are identical denominators. These are already common denominators. So I could actually write this entire thing, since this side is over a common denominator, I can combine the numerators to 5 minus 24k, and then this minus applies to both of these, so it's minus 8, all over the same denominator, but I'm going to write the denominator in factored form. Okay, you need to be getting pretty good at recognizing some of these factored forms, but if you can't, you can go back up to your diamond method or your X method. The last number goes on top. The middle number goes on the bottom. We're looking for things that multiply to equal the last number and add to equal the middle number. Well, in that case, this has to be a negative 1 and a positive 3. because negative 1 times 3 is negative 3, negative 1 plus 3 is 2. So my parentheses that this factors into is k minus 1 and k plus 3. We can take that shortcut and not have to do the whole factoring by completing the square. So that's the left side of the equal sign now. And this is still the same on this one. All I've done is factored it and kind of made it simple. Now I want to identify the least common denominator, which is this combined denominator. So I'm going to multiply both sides by k minus 1, k plus 3, on this side, it completely cancels. So I'm going to have just this, but I'm going to combine my like terms 5 and minus 8 here and change that to negative 24k minus 3. And on this side, the only thing that cancels are the k plus 3, so it's 3 times k minus 1. I'll distribute it to both of them. 3k minus 3. Now, since I've got a negative 24, I'm going to do this a little differently. I'm going to add 24 to both sides. And I'm going to then add 3 to both sides. And I'm showing my work this time. Now, that cancels the 3's here, but it also cancels 3's here. So when I bring this down, on the left side of my equal sign, everything canceled. So I have a 0. But on the right side, I have 27k. Well, the only thing to do now is divide by 27. 0 divided by anything is still 0. So k is 0. Now, I forgot to talk about my excluded values, but from this line here, the only excluded values I would have would be positive 1 and negative 3. Okay, so k cannot equal positive 1 or negative 3. All right, so we're okay. K equals 0 is my answer. Okay, so let's keep on moving. All right, on this side, okay, we have very simple denominators here. We have 3x and 3x. This is not a fraction. This is just the number 1, but the denominators 3x, that's still our least common denominator. It also shows me that x cannot equal 0. So my least common denominator is 3x, so I'm going to multiply both sides entirely by 3x. On the right side, it'll cancel, so it's just equal to x minus 6. On the left, I have to do 3x times 1 and 3x times all of that. The 3x times 1 is just 3x, but when I do 3x times all of this, it cancels that 3x. So it gives me plus x squared minus 5x minus 24. Now, I did not factor that originally because I don't want to, because I've got a like term, 3x, I can combine with that. So before I factor anything to try and solve this, this is a quadratic because my highest power is x squared. That means I have to get everything equal to 0. So the first thing I'm going to do is combine like terms on the left. The x squared comes out front. 3x minus 5x is minus 2x, and I bring down my minus 24. But that still equals x minus 6, so I have to subtract x from both sides, and I have to add 6 to both sides, which turns this into x squared minus 3x minus 18 equals 0. Now, I could solve this a lot of different ways, but the easiest way to start with is to check and see if it factors. And this one does factor. Okay? Each of these are an x in the beginning, and if you use your diamond method, negative 18 goes on the top, negative 3 goes on the bottom. The two numbers that multiply to equal negative 18 but add up to equal negative 3 are negative 6 and positive 3. So it's x minus 6, x plus 3. Since these two factors equal 0, either x minus 6 equals 0, so x could equal 6, or x plus 3 equals 0, so x would equal negative 3. So we get two different answers this time, and double check. Make sure these are not excluded values, and they're not. So this would actually work, x equals 6 and negative 3. Okay, one final example here. All right, and again, this looks a little more complex, but again, factoring the denominators is really going to help you, because if you look at this, these have a common factor of n squared. So this is actually 5 over n squared times n plus 5 equals 4 over n plus 5 plus 1 over n squared. Now let's do a couple things here. First, we want to look at excluded values. N can't be 0 because of this, n can't be negative 5 because of this, and those are the same two factors here. So n cannot equal 0 or negative 5. Now we want to look at the least common denominator to clear out our fractions. Well, the least common denominator is just that combined expression. So I'm going to multiply both sides by n squared parentheses n plus 5. On this side, it cancels completely, so that left side of my fraction is 5. On this side, for the first, when I distribute this to the first expression, the n plus 5's cancel, so it leaves 4n squared. And on this expression, when I do that, the n squareds cancel, and it leaves plus n plus 5. And so what we're going to do is we're going to solve this by recognizing it's a quadratic. The highest power is n squared. So I have to set it equal to 0. So I'm just going to subtract 5 from both sides. But what you notice happens is the 5 cancels. The 5's cancel. So that leaves 0 equals 4n squared plus n. Now, this is still a quadratic. But notice, there's a common factor out of these two. It's only a two-term quadratic. There's only a common factor of n. So I'm just going to factor out the factor of n, leaving 4n plus 1 equals 0. Now, according to my factoring rules and solving this by the roots, that means either n equals 0 or 4n plus 1 equals 0. But I already know n cannot equal 0. It's an excluded value, so I don't even consider that answer. So my only answer comes from this one. Subtract 1. And then divide by 4. So n could be the fraction negative 1/4. And that's the only answer that actually works. So pay attention to your excluded values. Now, if both answers here worked out to be my excluded values and no other answer was available, okay? I'll even write that at the bottom of my page. If no answers work, we write no solution. Okay? So if none of your answers actually work because they're both excluded values, you'd write no solution. All right, that completes our notes. This should give you a pretty good idea of how to work through this assignment. If you have any questions, please come see me as early as you can when I am back in class.